Hello and welcome to Microsoft Hates Greg. My name is Greg Deckler, and the title of this video kind of says it all, right? Did the 100 million row fact table star versus flat, right? And didn't really see any much in terms of the way of a difference in the DAX, right? And it seemed to be a popular video and got people talking about this subject. So what I decided to do, and then I did my other video around the philosophy behind star versus flat potentially, and kind of tying that to supply chains within World War II and all that. So that was kind of did that video. So this is the one more technical video, and I have more videos after this on this subject. Trust me. Um, but in this video, what I decided to do was, and we're on my SQL server, Adam Suxton, right? The most powerful man in the universe, that creepy stalker guy. What I did was I went ahead and took my 100 million row fact table, right? And I just, did a select top 1,000 and created a 1K version of it. And that, top 10,000 did a 10K and a 100K and a million, right? Fact table. And then I used 50 million because I already had it. So I just used that for the 10 million version. And then also my 100 million. And I figured I'd go back through and run the same performance analyzer tests across all of them. And so that is what I did. And so it was the same process. I'm not going to bore you guys with, because boy was it monotonous. I mean, my God, doing this over and over and over again. But so I took, like, here, for example, where my star 10K and my flat 10K. So I'd go to view, performance analyzer, bring up performance analyzer, start recording, hit refresh, right, 10 times, export it, go on to the next page, do it again, next page, do it again, right? So it did that for all the different versions. And yes, they're all out there in the flat star directory, which is going to be linked in the description, right? Every time I talk about this, I include the link to that file folder. If anybody wants to go and do it themselves, right, and verify all the stuff that I'm saying. So did that, right? Now there were a couple of differences, and one was I didn't include the year to date card, and that is because it it depends on how many rows you have in your fact table whether or not it works. Can't make this stuff up. I swear to God. This card table right here is the same DAX code that is used, in the 100 million row one. It's your standard calculate and dates YTD, right? Pretty standard. You'll see something like this a lot out there in the wild, and in books on the subject and in Microsoft's documentation on these things. And but yeah, they depend on how many rows you have in your fact table, whether they work or not. Yeah, I mean, if that's what you want to build the basis you want to build your report on, sure, nobody's stopping you. But would I recommend it? Probably not. Now, the other issue with the same calculation is you can see that with our no calculate version, right? We have, we only have one date in this table, in our fact table, right? It only includes one order date. But again, the standard way of doing it with calculate and time intelligence, it has no concept, right? That is the case, and so it goes and calculates the damn thing for every single date, which isn't wrong per se, but is it smart? No, that's not a smart way to do that. Whereas you don't have to worry about that in the flat table with the no calculate. It behaves properly, in my opinion. And you're going to say, well, Greg, isn't that going to skew your results? Yes, we'll get to that when we get to the performance analyzer report, right? We have a way to exclude year to date so that we can compare it without the stupidity of the calculate and time intelligence being there, right? But before we get to that, a couple things. I went and documented the file size and the memory size of each one. So you can see the file size of 1K flat versus 1K star is 239 kilobytes versus over a meg, right? And you have this, and the memory footprint is 738 versus 3 megs, right? 738 kilobytes versus 3 megabytes. And we'll get to the explanation of this, but one of the things, and these are the kind of things that like make you realize that you're an idiot. I had been talking about the difference in the refresh speeds between the flat and the star. And then I realized, well, duh, of course, because I'm taking a star schema and I'm flattening it, right? I'm doing extra work. And also, when you do more than one join, it seems you seem to break query folding in that. So yeah, it was taking a lot longer. So one of the other things I did on my Adam Suxton server is that I did this fact internet sales flat 1 million. So I pre-joined all the data for a million row fact table, and instead of doing it in Power Query. And then lo and behold, the refresh times were basically identical between the million row fact table, flat table, and the million row star schema fact table, and those models, right? So it came out. So I can eliminate refresh as like it's the same as long as you pre-join your data and don't make your Power Query do extra work. So there you go. Um, so now you see this again happen with a 10K flat and 10K star. Again, the star scheme is bigger file size, bigger memory footprint. It starts to even out here at the 100K level, right? It's a little bit bigger so as far as the flat table versus the star schema. And the memory footprint is actually smaller at 100K versus the star schema. And then after that, right, you start to get to where the million row flat table is bigger file wise and bigger memory footprint than the $1 million star. And this is pretty consistent throughout. Although what we're talking about in terms of the differences is generally around 10 to 15%, right? If you run these numbers and that sort of thing. And this is also out there in the flat versus star folder directory. This is also there. So now, why is it this? Like, I could sit here and like, claim victory and like this is see, they've all been lying to us so about flat versus star and at small sizes the flat table is so much better, right? Well, not so much, but then again, potentially yes. Uh, let's get into that. So what's going on here is that I only have 1,000 rows in my fact table, right? So here's my total size and memory. But as you can see, like for this is the 10K star schema, this is the 10K flat. As you can see, the customer table is humongous, right? And the reason for that is because I'm importing all my customers, even though not all my customers bought something in those 10,000 row fact table, right? So that's why this is so much bigger. And so you're like, oh, great. So that explains why at these smaller sizes, right? You have this huge customer table because, I'm not importing just the customers that bought stuff for those 1,000 rows or the 10,000 rows, right? Makes perfect sense. Now, so you can claim that as bias or whatever you want, but I would also point out that are you doing this in your production systems? Let's say that you only import the last 2 years worth of data from your fact table. Are you going to your customer table and making sure that only the customers that bought in the last 2 years are in your customer table, right? Or are you just importing your customer table and like, memory and file, file capacity or in storage is cheap, right? So I don't really care. I don't need to only import the customers that bought in the last 2 years. Is your date table, is it, kind of standard what I see with tables out there where they hold like a decade or two worth of data, dates in them? Or is it just the last 2 years of dates that you're importing into your date table, right? Same thing with products and other dimensions in that. Are you verifying that, you only have the products, the customers, the dates that are in your fact table in your dimensions? Or are you just kind of being lazy about it and be like, that stuff's cheap, so I'll just import the whole customer table, I'll import the whole products table, I'll import the whole date table, right? Because I kind of get the feeling that you probably are being lazy, right? You're probably not cleaning those tables up and only importing the stuff that you need, which means that your flat table, your stars table is going to be eating more memory and more disk space than it should, because you're probably being lazy about it. So something to think about. All right, so now we can get to the actual performance analyzer data, right? And let's get rid of this, select all this. So now you can see down here, like 100K flat versus 100K star, right? You know, DAX query time is way better for 100K flat versus star. Same thing for 10K, same thing with 1K, same thing with 1 million, right? Same thing with 50 million, same thing with flat 100 million, right? They're all better than the star schema in terms of performance. But remember what we said, the year-to-date stuff. So if I just select like 1K, let's unselect this, 1K flat, 1K star, And then up here, I go ahead and yeah, I've got it basically drilled down, right? So in this case, I added the actual test, the category test, into it as in the hierarchy. And you can see that for year to date, it's 43 milliseconds versus 516 milliseconds. And so if we get rid of the year to date and we go back to this, now you can see that everything is pretty much identical, right? Like right across the board. And I was actually I was a little surprised by this in terms of the just how little difference there is between your 1K flattened star and the 100 million flattened star in terms of the actual performance is almost the same between them, which I thought was really interesting overall. Um, anyway, I would have expected there to be a bigger difference, um, and that the 1K fact tables would be a lot faster than the 100 million row fact tables. But they're not. At least not in my testing. The testing that I did in terms of the DAX queries and that the performance overall and stuff, there's not a lot of difference. Which I don't know. Was not expecting that. But overall, like you can see, I mean, 100K versus 100K star, flat versus star, 10 milliseconds worth of difference. And the flat's faster, right? And 10K flat versus the 10K star, the star scheme is 10 milliseconds faster. And the 1K flat, the flat's 40 milliseconds faster than the star schema. So I think overall, it's all probably within the margin of error in terms of the difference between the flat and the star. But mainly the flat table, there's only two instances there. It's the 10K flat versus star and the 50 million flat versus star, that the flat table is slower than the star schema. But again, I would say they're basically equivalent. I mean, I in my opinion, looking at these numbers, I just don't see a lot of what I would say statistically significant difference between them. Um, so again, I've got more to say on this, but in terms of performance, you're not gaining anything by using a star schema versus a flat table um, for anything up to 100 million rows, at least from my benchmarks and my testing that I've done. Maybe there's somebody out there, and I hope there is, that's way better at benchmarks than I am and can come up with way better benchmark tests than I have come up with. I just used basically the SQL BI benchmark test that they used in their article where they claimed that star schemas were the fastest, most brilliant thing ever compared to flat tables, and flat tables suck. Um, Shoddy information, okay? And you'll be, as I've gone back through SQL BI, I've been really shocked by how shoddy a lot of the information is in their articles. And I'll get to that in one of the next videos that I'm going to do on this subject. But yeah, there it is. But again, yeah, the last thing I'll say is, excluding this year to date. Well, if you're using a star schema, you're probably using that crappy DAX code, right? Time intelligence and calculating your DAX code, right? So yeah, you're probably costing yourself time and money doing it, as a star schema and using the crap DAX, with calculate and time intelligence, DAX time intelligence. So be careful out there, folks. All right. That's all I had for this video. Hope you enjoyed it, and I'll see you next time.